Today, let's talk about the scientific revolution, the intellectual revolution that occurs roughly in the 17th century. It certainly begins to build before then with Copernicus and the so-called Copernican revolution. But it continues to build into the 17th century with figures like Johannes Kepler, Isaac Newton, and then on the intellectual revolution side, we should mention Michel de Montaigne, René Descartes, Francis Bacon, the English philosopher. So there's a number of figures really who are important for us to discuss. And what we're talking about really is just a complete change in the paradigm of how nature is understood, how it's looked at, the relationship of mankind, humanity to nature, and really what the entire physical universe looks like, or I should say really the cosmos looks like, because nobody thought that the cosmos was actually a huge infinite universe, which was exactly the work or the idea that was the implication behind the work of Galileo. So how does all this transformation come about? What we're talking about here is a tremendous upheaval, because remember, if you go back to the medieval period, the church, theology really dominates everything, and people live as much for the next world as they do for this one. There is no such thing really, certainly nothing like modern science. The notion that there is such a thing as a sort of detached, independent discourse, which can be called science, is something that's only gradually emerging. It really takes a sort of a challenge, excuse me, it takes a challenge to say that actually the cosmos is quite different than the way that it's been presented, not only by medieval science, early science, Ptolemy the Egyptian, for example, way back toward the time of Christ, but the church had picked up on that and defended it, and really it was the notion that that the cosmos is very limited, it's finite, and space is very different, so that the closer you are to Earth, the more material everything is, but as you get further away, you get to the outer realms, and of course you're going to find the heavenly realms, the spiritual realm, and so on. Space, in other words, is quite different. The universe is actually a limited cosmos, not an infinite universe. So how do we go from the much different idea about what the world looks like to the scientific revolution? Well, several things happen. We've talked about the Renaissance in the past. The Renaissance certainly begins to challenge the inherited ideas that others had insisted upon. So what are those kinds of challenges? Well, the church had always said that the earth is the center. It's God's great creation, mankind on earth, and that's the center of this limited cosmos. The sky, the stars, they are kind of a fixed firmament, a ceiling, if you would, and beyond that is the heavenly spheres, up through the angels, all the way on up to God, and so on and so forth. When you get to the Renaissance, that idea is beginning to be challenged already, although in a very strange way, by mystics, for example, who begin to think, really a lot like Plato had once said, that everything we see around us actually is a kind of illusion. The way things appear to be is not really the way they are. And a number of thinkers begin to think, well, maybe we can understand things mathematically. Strangely enough, mystics begin to think like that. Maybe we can understand things mathematically. And another thing is maybe we can begin to understand things, and we should not simply rely on authority. That was the great message, of course, of the Renaissance, that mankind could actually discover its own truth, that there was no such thing as a fixed essence. That was precisely even the thinking of Machiavelli. So that change is always happening. We're not to the point of evolution, but nevertheless, there is change. There's no fixed essence. Even human beings change dramatically. Even human nature evolves. So this kind of thinking was very much typical of the Renaissance. On the scientific side, you've got Copernicus. And Copernicus, of course, is somebody who begins to think that takes the same idea that the way that things appear to be may not be the way they are. And he's able to use mathematics in order to figure out that actually the cosmos is not the way that centuries before had thought it was. That is to say, we don't have a geocentric cosmos. It is a heliocentric, that is, the sun is the center. And so it begins to stretch, change the so-called inherited truth. It begins to challenge it. Of course, the church was not happy with Copernicus, but later on, it doesn't take too long, when Copernicus' ideas are going to be confirmed. Several people along the way will do that, but particularly the work of Johannes Kepler. Kepler is able also to build on the mathematical foundations before him, and he is able to figure out that the orbits of the planets are not circular the way that they were supposed to be according to inherited wisdom. And what he observes, not observes, but what he's able to figure out mathematically is they're not circular, they are elliptical. What he has discovered is a relationship of time and movement or motion, that there is a relationship. And the closer a planet would get to the sun, for example, the more it would speed up. And he's able to even work out a formula which shows the relationship mathematically. That relationship, of course, that elliptical pattern that he's talking about is gravitation, but he doesn't know that yet. He doesn't have the formula for that. He's not figured it out, but he's on the way to figuring it out. When you come to Galileo, lives a little bit later, Galileo is already, of course, challenging the limits of inherited reason also. It helps quite a bit that he develops a telescope in 1609. He's able to observe the planets. He's able to observe the moon. What he's able to find out, just by simple observation, is that the moon looks very much like the Earth. It's got craters, and what he's able to conclude from this is that, you know what, perhaps matter is the same everywhere. Perhaps matter exists not only here on Earth, but elsewhere as well. He's beginning to challenge the notion that space is divided into a more material area and a less material, or maybe a more spiritual order or area. And so this gets to the idea that perhaps whatever the cosmos is, whatever the universe is, that there is no distinction, there's no ascending order in terms of how space is organized. And that, of course, could challenge the notion that beyond the stars, beyond the firmament, there is another area altogether where God presides. And he conducts other experiments. For example, he comes to realize that space is uniform when he begins to drop different things which have a different weight, but they nevertheless go through space in more or less the same way. That is to say, they obey laws that seem to be universal physical laws. He also conducts some experiments, and he realizes that once something is in motion, as long as that object is in a vacuum and there's nothing to delay it, there's no friction, that it would stay in motion forever. What he's talking about, of course, is terrestrial motion, right? And what that means is that if something is unimpeded at all, that it could stay in motion forever. And what he concludes from this is that actually this is possible, that the various things in space, the various bodies in space, there's absolutely no reason whatsoever why they could not have been moving, why they could not have been in motion forever, eternally. And that suggests something, of course, which is very much in conflict with what the church had said, with the point of creation, right? God created the world in a particular moment. And here's Galileo suggesting that perhaps motion has always been there, perhaps the bodies have always been there. Something actually which goes all the way back to Aristotle, who had also implied that perhaps the universe was eternal and didn't need a moment of creation. So here is Galileo, really on the point of saying some very dangerous things. The church told him to shut up, and basically he did not publish his work for something like 20 years. I think it finally came out in 1637. His work was obviously revolutionary because of a couple of things. And one, I just said, it suggests that space is uniform everywhere. So where are the heavens? Where is God? And the other thing was, perhaps the universe was eternal, and if that's true, it doesn't need a creator. It doesn't need creation. And if all that's true, if an object can actually go into motion forever, eternally, then there's no limits. We're not talking about a limited cosmos anymore. We're talking about an infinite universe. This is really a revolution. Fast forward a little bit to Isaac Newton, who lives until 1727 in the 18th century. And, excuse me, Newton was the one who really reconciles the planetary motion, celestial motion, that was discovered by by Kepler, with the terrestrial motion that was discussed by Galileo. And of course, what he finds is that actually there are two different sort of corollaries to the same law of physical motion, the same physical law. What he's talking about, of course, is gravitation. That's why planets pull back and go into elliptical patterns, right? Because of gravitation. He actually works out the formula for that, which is part of his calculus. And the formula is that every particle attracts every other particle in the universe with a force which is inversely proportional to the square of the distance between them. There, I got that out. All this suggests that the universe can be on its own. It has its own laws. And of course, Newton, who was very sensitive on that point, and who was not an atheist, says, well, what happened was that God created the world, he wound it up like a clock, and then let it go on its own. That's how he left it, but he also left it by saying, well, we can understand everything by these laws. We can actually develop a science. We can actually come to understand the material universe by using reason, logic, and science. And so here was an enormous challenge to the way that people had thought before, enormous challenge to the official position of the Catholic Church. It was obvious that the physical understanding, the understanding of the physical universe would have to change. Corresponding to these great scientific figures, let me mention a couple of intellectuals who are very important too, because they're also trying to revise how people think about that world and really how they think about truth in general. Certainly the church and the whole notion of truth was that truth is absolute and unchallengeable and eternal, therefore, right? That truth is something which is sort of given to us. It's in nature, and it's our job to sort of understand it by reading nature. That was how the church saw things. Well, then you, excuse me, you get several intellectuals. I'll mention Michel de Montaigne, the great French essayist and philosopher who lived in the 16th century and comes to be a great critic of the Catholic Church, at least up until his death, when he decides, well, maybe I'm wrong and I better take confession, which he does. But he also raises the question, which kind of precedes his entire philosophy, que sais-je? What do I know? And what he's suggesting is that there is no such thing as universal truth. Truth varies with culture, it varies with experience, it varies even with the individual sometimes. He's been accused of being a relativist, but what he was doing was, he was saying it's very important not to receive authority as the basis of truth. It's very important for us to make our own observations. So in a sense, you could say truth begins with Montaigne, at least the way that he understood it, that each individual has to decide for himself and do his own thinking. This was a dramatic sort of departure from the way that things had been before, but it was also very typical of the Renaissance in that Montaigne was suggesting that the individual should, in fact, be able to use reason and to judge experience and to come up with truth or truth for that particular individual or that particular culture. And he's very famous for his essay on cannibalism, in which he suggests that cannibalism was just as natural as anything else. because that was the experience of this one group of people, that they practiced cannibalism. There was nothing to say that that was a lower order or a higher order than those who did not practice it. This didn't win him many friends, of course, in religious quarters or perhaps in others as well. But it was an interesting way of going about understanding. What he was doing was saying that we can't do what used to be done, assume that there's such a thing as an essence, and then deduce everything else from it. Truth, in other words, is not something which is deductive. Truth is inductive. It is something that we generalize. We generalize from experience, and the truth is something that corresponds to that generalization, right? Something appears to be true based on the experience we've had. This idea would be taken even further by others. Francis Bacon, for example, would be one, the Englishman, who came to believe that actually knowledge, if knowledge is something that we derive ourselves, if knowledge is something derived from experience, if knowledge is based on our reason and its ability to induce or generalize, then in fact that our understanding can correspond to the way that things actually are. Nevertheless, truth is inductive. We generalize upon it. But what's important about him was that he understood truth to be sort of the really kind of a scientific basis also. Isn't that what scientists do? They observe things and then they generalize from that. So he developed this notion that basically knowledge is power. This phrase, 3 words, knowledge is power. Because we can understand things even though we're generalizing, and truth may actually change depending on our experience. But we can generalize, we can reach a sort of provisional truth, right? And that gives us the power to transform nature. Extraordinarily important idea for the development of science, because it means that reason can be applied to nature, and that is what gives thought its great power. Other thinkers, very important, certainly I would say the most important perhaps of them all, René Descartes, who lives until 1650. Frenchman, writes a very interesting work, A Discourse on Method, in 1637. And he was the one also, he's looking for a point of departure for knowledge. Montaigne had already said, what do I know? And that suggests that I, in this case, am the beginning of what knowledge is going to be. Descartes is the one who will expand on that idea. You notice this is a direct challenge to dogmatism. It's a direct challenge to inherited authority. It's a direct challenge to inherited truth. And that is exactly where Descartes is. Descartes asked a fundamental question, and more or less the same question that Montaigne had asked. And what he finally says is he's looking for the one thing that is absolutely that cannot be contradicted, the one principle of thought that cannot be contradicted. And what is it? It is, he says, cogito ergo sum, I think, therefore I am. That cannot be challenged, because if you say it's false, it's impossible. It's a logical self-contradiction, according to him, because the statement, I think, therefore I am, is analytically true, because if it's doubted, you still can say, who's doing the doubting? For him, that was, for Descartes, that was a radical departure, and it was. It was a new beginning of thought in a lot of ways. So Descartes is suggesting that that it's possible, because the mind is so ordered that it can employ reason and logic, that it has the capacity to understand truth through itself. Being a mathematician, of course, it's not a surprise that he would make such an assertion. So for Descartes, he believes he has discovered the sort of what philosophers have always been trying to do, to find that point at which thought and extension, mind and matter, can be reconciled. How do we know that we understand? How do we know that consciousness can actually understand inert matter, right? Nature. And what he's saying is because our mind is ordered in such a way that we can do it, and we cannot, it's impossible to doubt our own thinking, our own mind. We know we exist, and we know that we can comprehend nature. There was a question that was still outstanding, however, and it was, how do you really know that mind, which is self-contained, can understand nature, which is out there? How do you really know that mind and matter actually correspond? And his answer was, God would not deceive me. And with that, I'll leave you until next time.